Have you ever wondered why algebra actually matters? Or how equations like 3x plus 5 equals 14 are used in real life? Well, you're in the right place. Whether you're budgeting your money, calculating travel time, or even figuring out how much food to order, linear equations are everywhere. So let's break these down step by step. So a linear equation is any equation that has a variable, so something we don't know, and in this case we'll use an x, anytime we have a variable that is raised to the first power. So all that it means to be in a linear equation is if we go to graph this equation, it forms a straight line. So for example, a linear equation might look like this, where our x value is 1 and or our y value is 1. Or you might see something like this. This is another example of a linear equation. And we know it's a linear equation because it's raised to the power, the variable is raised to the power of 1. So what are some examples of non-linear equations? Nonlinear equations are anytime our variable, or x or y, or whatever you're using for your variable, is raised to a power greater than 1. So y is equal to x squared is a non-linear equation. So in other words, when you go to graph this, it's going to form a non-straight line. Or you might see something like this, 2x third plus 3 is equal to 10. So you might recognize that these two things look really similar. The only difference being that our exponent is completely different. So if our exponent is 1, we will form a linear equation. If it's not, we will form a non-linear equation. So let's look at some real-world examples, because oftentimes you sit in a math class and the math teacher says, well, you're going to need to use this someday. And you think to yourself, where would I ever use a linear equation? Well, let's look at a couple of basic examples. So let's say that you have $10 a week. So you have $10 a week, whether you have an allowance or a job or something like that, and you want to save and make that $10, you want to save until it's $1,000. And your question is, how many weeks would it take for me to save to get to $1,000? Well, we can write a basic linear equation, algebraic expression, to model this. So we make $10 a week, and we don't know how many weeks we have. So that is our variable or our unknown. So in this case, this is weeks. And we want to know how long it takes us to get to $1,000. So this is the algebraic expression that models this example. So let's use a different example. Let's say, for example, you're driving in a car with your family or your friends on a road trip, and you're traveling at 60 miles an hour. So you're traveling at 60 miles per hour. And you want to know, well, it's a total of 400 miles to get to my destination. How long is it going to take? Well, again, we can model this with a linear expression. So we know we travel 60 miles per hour, and we have some variable that we don't know. And in this case, our variable is time, so hours. And we want to know how long does it take to go 60, or how long does it take to go 400 miles when we're traveling 60 miles per hour? So linear equations help us predict and plan things in real life, like money, time, travel, and much more. So let's look at some examples of how to solve basic linear equations. So I'm going to start with an example like this. X plus 7 is equal to 14. So this is an example of a linear equation, and you might have the instructions to solve for x or solve for your variable. The best way to think about a linear equation is by using a scale. So think of a scale, and on the left-hand side of the scale, let's say I have 3 different weights, and we'll call these weights 5 pounds each. And on the right-hand side of the scale, I also have weights. also 5 pounds each. So if I have a total of 15 pounds on one side and 15 pounds on the other side, I have a completely balanced scale. If I then take a weight off the left-hand side, what happens? Well, the scale becomes unbalanced. So if I'm going to take a weight off the left-hand side, to make sure it's balanced, I also have to take a weight off the right-hand side. So what I do to one side of the scale, I have to do to the other to keep it balanced. It's the exact same thing when we're solving for linear equations. Our goal when we're solving for linear equations is to get the variable, x in this case, by itself. So how do I do that? Well, I need to move this 7, this positive 7, to the right-hand side of the equal sign. Going back to our scale analogy, if I move this to the right-hand side of the equal sign, I have to do an equal operation on both sides of the equal sign. So in other words, if I take a 7 from the left hand, I must then move it to the right-hand side to balance this equation. So let's look at what that looks like. In this case, we have a positive 7. So we have a positive 7. So in algebra, to undo or to move something to the opposite side to the equal sign, I have to do the inverse operation. So the opposite thing. So I have a positive 7. So the opposite of positive is negative. And I want to move this 7 from the left-hand side to the right. So I'm going to subtract 7 from the left. I'm also going to subtract 7 from the right because what I do to one side, I must do to the other. I draw a line here. Now let's simplify some things. Well, I'm always going to work left to right. So on the left-hand side, I have not done anything to my variable or my x. I'm going to bring that down. And then I'm going to take positive 7 and subtract it from negative 7. Okay, so 7 minus 7 is 0, so I can cancel those out. Or if you wanted to, you could rewrite this as plus 0 is equal to 14 minus 7, which is 7. Okay, I could rewrite this because 0 has no value here, so I could rewrite this equation as x equals 7. Okay, so we followed all of the rules of the scale analogy. So we move something to we move something from the left-hand side to the right-hand side, and we did the exact same thing. So we removed a weight like we did here on the left, and then we also did it on the right. Okay, and then we simplified. Now, the really cool thing about algebra, and you might be thinking, maybe there isn't anything cool about algebra, or my teacher thinks algebra is so cool, but it's not. I'm here to tell you that maybe it's slightly cool and actually is really cool when we start applying it. But the cool thing about algebra is if you get to an answer and you say, how do I check this? How do I know if I'm right? Well, there is a way to check this. So anytime you get to the end of a problem, we want to plug that value back into the original equation. So for example, we said x is equal to some value 7. Beforehand, we didn't know what x is equal to. So to check our answer, we're going to replace x with 7. So I just replaced this variable with the 7, and now I simplify. So in order for this to be a true expression, one side of the equal sign has to be the same as the other. So let's see if that's true. 7 plus 7 is 14. And the question we're asking, is 14 equal to 14? Well, yes it is. So we know now that our algebraic expression, the steps that we took in solving this algebraic expression were legitimate. Okay, so 7 is our answer, and we proved that here by plugging it in. All right, let's do another example. Let's take x minus 3 is equal to 27. So let's go back and break down the big ideas. So we're going to try to solve for x, get x by itself. To do that, we need to move this negative 3 to the other side of the equal sign. What we do to one side of the equal sign, we have to do to the other. So let's do it. We know this is a negative 3, so we're going to do the opposite or the inverse operation. So we're going to add 3 to both sides, because what we do to one side, we must do to the other. Negative 3 plus 3 is 0, so I can cross those off. And I'm left with x is equal to 30. okay? And again, the cool thing, maybe not cool to you, but cool to me, is that at the end of any time we solve for something, we can plug it in and see if we got the right answer. So let's plug in 30 for x minus 3 is equal to 27. Let's see if this is a true expression. 30 minus 3 is 27, equal to 27. So the question we're asking is this a true expression or is this a true statement? And it is. So therefore, we're happy. Okay, let's do one more. Let's go down here and let's say 3x is equal to 30. Okay, this one's a little bit tricky. So again, our goal is to get x by itself. So we want to move all of the constants, and in this case, our constant is 3, to the other side of the equal sign. So how do we do that? So anytime we see a number or a constant next to a variable, we assume that there is a multiplication sign in between those two things. So we know that the opposite of multiplication is division. And we also know that if we divide one side of the equal sign, we must then divide the other side. Okay, so let's try that. So 3x divided by 3, we're dividing one side. So what we do to one side, we must do to the other. Okay, and let's see what happens. Anything divided by itself is just 1. So I'm going to cross this out real quick. And I'm going to write 1x, which is what we're left with, is equal to 30 divided by 3. Well, that's 10. Okay, there's our answer. We can also write this expression as x is equal to 10. Anytime we have a 1 in front of here, we assume it is a 1. We assume this is a 1. So therefore, we can also just leave it blank like that. So x is equal to 10. So let's check it. I'm going to put 10 in for x. So we have 3 times 10, because there was a multiplication sign between those two, is equal to 30. And let's see if this is a true expression. 3 times 10 is 30, is equal to 30. So is this a true statement? Well, yes, it is. Therefore, we know we did it right. Okay, so let's go back up and let's summarize this real quick. Okay, so we talked about linear versus nonlinear equations. So for it to be a linear equation, we must have a value of 1 for our exponent. Nonlinear equations have a value of 2 or greater. We also talked about how there are lots of applications for linear equations, whether you're figuring out how much you want to order for food, or budgeting groceries for the week, or speed of a car, or we're talking about budgeting just in general. We can use linear equations. We talked about the scale analogy, and so what that meant is that we need to keep the scale balanced. And to do so, once we take something off the left-hand side or do something to the left-hand side, we must do the other thing or the opposite thing to the other side, okay? So if I'm taking a weight from here, I must also take a weight from here. And we showed that in this example where we did this, okay? We also saw a different example where we're doing the opposite or the inverse operation to get this -3 to move over here. We do the inverse operation. We also did and saw this here. So we had a multiplication and we divided. So I'm going to leave you with this. I'm going to leave you with the expression 6x is equal to 24. And I want you to solve this on your own. So pause the video real quick and solve this on your own. Once you get the answer, put it down in the comments. If this was helpful for you, please hit and subscribe. Hit the like button and subscribe for more math tips. Up next, we will cover two-step equations, so stay